Hello everyone and welcome to the part 2 of types of aquifers under this groundwater engineering course. So, in the previous discussion we have learned two types of aquifers, one is confined aquifers and unconfined aquifers. So, let us go through the other types of aquifers. So, this confined aquifers and unconfined aquifers we have seen, these are the two extreme members among the types of aquifers. And then there are other types of aquifers which we will discuss in detail in this discussion, that is the Aquitard, another one is the leaky aquifers, name shows something or name indicates something about that. Then we are having aquiclude and we are also having aquifuges, and lastly we are having Artesian aquifers, which is a rare phenomena, but it is seen even in this country or many parts of the world. So, that part we will also discuss. So, let us bring now Aquitard. Aquitard basically is a low permeability unit that can store groundwater and also transmit water very slowly from one aquifer to another. Maybe because of an example here is given like sandy clay. So, clay, because of clay the movement is slow, and the characteristics of clay you might be knowing that as soon as it comes with the contact with water it swells, and therefore, once it swells it does not allow water to move very easily from one end to another. And so, if layer is sandy clay or clayey layer or clayey sands is there, then that cannot be called as a typical aquifer, or then it is called Aquitard. So, you can remember simply Aquitard means the movement of water is very slow, and the overall the permeability, that is the movement of water within subsurface condition is very low compared to normal aquifers. Though it permits water through, but does not yield water in sufficient quantity as aquifer does, and that is why in many conditions where no water is available and no typical aquifer, confined aquifers are available, not even unconfined aquifers are available, only Aquitards are available, then still water can be withdrawn, but not of large quantity. So, it cannot be used for irrigation or industrial purposes, but in some cases it can be used very judiciously for drinking water purposes. So, that is there. So, what here we see that we are having a top of here unconfined aquifer, then we are having Aquitard, and then we are having aquifer, and then again a confined aquifer, then we are having Aquitard. That means the Aquitard layer is not fully confining, not perfectly impervious. It will allow water to move from one place to another, maybe in vertical direction and of course in horizontal direction too. So, it is not a typical in that sense a confining layer, and it is because their low permeable nature. So, because of that only the movement of water is slow. Further, Aquitard, this is an aquifer under the Aquitard, then the water from Aquitard may seep into aquifer. This is what I was mentioning, that because it allows the water to go downward as well, may allow, and then it can recharge the groundwater. A confined aquifer may be very slowly. So, in that way it is good that you are having an confined aquifer on the top, you may recharge this groundwater, this regime, and then you know that next layer is the Aquitard. So, it will slowly recharge my confined aquifer also. So, sandy clay materials and like in Indo-Gangetic plains, this is a huge part of the country is having similar kind of examples, but it is not continuous that throughout the aquifer, throughout the Indo-Gangetic plain you are having the same Aquitard layer. No, in between there are layers, clayey layers, perfect clay which does not allow water means impermeable layer, or they are having Aquitard situation also. So, here the clay particles, as I have said also, that the block the voids present in the sand and make it partly permeable, not fully permeable. If it would have been only sandy or sandy sediments of larger size compared to clay, then that problem will not come. So, if there is an aquifer under the Aquitard, then the water from Aquitard may seep into aquifer, The sandy clay is perfect example of an aquifer, and here the clay particles blocks that one. So, now we come to this leaky aquifer, another type of aquifers, and name indicates that again more or less it is coming very close to in that sense about the Aquitard, but not exactly. And so, an aquifer which is overlain and underlain by an Aquitard is described as leaky aquifer. So, in earlier figure, if I can bring that one, then in a purely definition point of view, then we should call this one as leaky aquifer rather than confined aquifer, because top or bottom layers are Aquitard. So, leaky aquifers, an aquifer which is overlain and underlain maybe by an Aquitard is described a leaky layer, and sometimes the bottom of this unconfined aquifer may be semi-pervious, and water may gain and lose through these semi-pervious bottom layer. So, bottom layer means that is Aquitard. So, in natural conditions, all these conditions may occur in natural situations, and especially I am talking about the alluvial, where you are having alluvial plains like Indo-Gangetic plain or in valley fill situation. Because when nature, when these sediments came, it is not necessary that all throughout the year or seasons or decades sediment size remains same. These keep changing by season and by other changes which occurs in the catchment area. So, the sediment, if the sediment within the sea alluvium, if the sediment size is different, then the types of aquifers will also change. So, here the leaky aquifer, given that this is allowing water to go up or down. Now, leaky aquifer which is bounded by two impervious layers at top and bottom of the aquifer is called confined. If it is bound by impervious, then that is not a typical leaky layer, then it is a confined aquifer, as also shown here on the right figure. And sometimes these layers may be semi-pervious in nature. See, these are the just schematics which you are seeing, but in natural conditions you may not find exactly the same situation, and especially in horizontal extent, because only in a section you may find something like this, but in a horizontal, in a large extent, aerial extent, you may not find same situation throughout the in a command area or a basin. But nonetheless, different situations and different natural situation, natural settings are there. So, different solutions for withdrawal of water, groundwater recharge have to take place. So, in such situation water may gain or lose through these semi-pervious layers, which in case of and this is all is about the leaky aquifer. Now, another type of aquifer which is called aquiclude, and this aquiclude, which is again a geologic formation, though it is maybe having porosity and capable and therefore capable of absorbing water, storing water, but impermeable. So, permeability is really very poor, and if permeability is very poor, then they may have water, but no movement can occur, and therefore these types of geologic formations are called aquiclude. Good porosity, but very poor permeability or no permeability whatsoever, means permeability will only happen if these pores are connected. If pores are not connected or these rocks are not fractured or there are different types of joint planes or other things are not there, then this kind of situation will come, and the rocks may be saturated with water, but no movement of water is possible. So, the bottom layer here is shown as aquiclude, and the examples, natural sediments examples are like clays. If it is a purely clay layer, then it serves as a aquiclude and shales, because clay can absorb water and it swells and then it cannot release the water so easily, and shales also which are also clayey rocks. So, that will also have the same kind of problem. Now, aquiclude, because of its high porosity, and clay is an example of aquiclude, we have already covered this part. Now, aquifuse, another type of aquifer which is aquifuse. So, it is absolutely impermeable geological formation, absolutely impermeable, no possibility of movement of water through it, neither porous nor permeable, and neither stores nor transmit, completely hard rock and no pore spaces, no permeability. And such kind of geologic formations in subsurface conditions are called aquifuges. Nothing can happen. Fuse you can take from electrical engineering or electronics, the same word is here. Fuse, no connectivity. So, compact rock is an example of aquifuge, hard rocks, typical hard rocks like batholith or granite batholith, or maybe other kind of these igneous rocks sometimes, or even metamorphic rocks may behave like this, that they are absolutely solid, there is no porosity, no chance of permeability, no weathering also, no cracks or fractures are there, and therefore it will not allow water to store or transmit. So, this is one example here is in a typical hard rock terrain in India, large part you can see here that this only top part is having lot of fractures. So, water can go there. Further also there are weathering zones, we call as weather. So, this part, the top part is maybe 0 to 3 meter from. So, only the top part may be having the weathered surface, then you are having cracks, joints and other things, and then this is your filled with water, means saturated, unconfined aquifer conditions. And of course, this is all because of fractures. So, in hard rock terrain, if weathering effects are deeper and lot of fractures are there, then the thickness of a unconfined aquifer may be good, but generally it does not happen, and that is why in dry season the well goes dry, because this layer is not very thick, and below that layer you are having a really basement rock, or you can say it here, though it is written fresh basement, means it is not exposed to the atmosphere, therefore there is no weathering, no fracture, nothing, it will work as a completely aquifuge, and therefore you do not have much space left to store the water. Even you may be having lot of rain top of this layer. So, that is the problem in hard rock terrain, and of course, this problem to some extent can be solved by recharging the groundwater regime, maybe unconfined aquifer conditions. Now, another type we are reaching almost last two types of aquifers. So, one is the purged aquifer and the last one would be the artesian aquifers. So, purged aquifers, again a very common thing, can be seen in Dugantic plain like this example, and also when we have been discussing water table, we also mentioned this purged water table. So, purged water table you can see again here, and there is a layer which is completely impervious, and because of the shape of layer or depression within that layer, it may have its own water table, that is purged water table, and this water can also be exploited. If a survey has been done very accurately, then you can find the purged aquifers also, but these are in aerial extent, these are very small. So, but the small water requirements are there, maybe say for drinking and other things, situation is like this, still these can be exploited. But unconfined aquifers as shown here, where and water table is here, so that if this well will yield a good amount of water, whereas this well will yield a relatively very little amount of water, but still it can be exploited. So, an aquifer that occurs above the regional water table. So, this is the regional water table shown here, this is regional water table, and then this occurs when there is an impervious layer, maybe clay layer in like Indo-Gangetic plains, rock or sediment aquiclude, or sediment or relatively impervious layer like Aquitard above the main water table or aquifer, but below the land surface. Of course, it has to be below the land. So, that kind of aquifer is called purged aquifer. Sometimes people will say that they are getting water in their tube well, but when I have created a well here at the same depth, I do not get the water. That means the person has missed the perched aquifer. So, then in that case he has to go little deeper, but this is only in case of this kind of scenario. In a hard rock terrain, deeper well may not yield anything. So, these are very risky things. Therefore, the better investigations will always help to get the sufficient amount of water, whatever the target, whether for drinking, irrigation or for industries. And lastly, we are having now artesian aquifer. These are very special conditions in subsurface formations when they make a kind of saucer or a bowl kind of situation, and then there you can see that this is the artesian well or also called flowing well. Because of water level, you see this is the area. So, water table is at this level. So, if you dig a well, you will get water flowing up to this level. So, that kind of artesian conditions are seen. Artesian conditions can also be seen where there are escarpments are there. So, water table in higher parts is much higher, and because of escarpment it has cut. So, again you can, if you are having just below there you are having some wells, they will be flowing wells, and sometimes say fountain kind of thing may not be there, but there might be a seepage kind of thing, that water coming from top and flowing. Let me give you an example. There is a zone which is called Bhabbar zone just below the that is the northernmost part of the Indo-Gangetic plain and before the Shivaliks. And this Bhabbar zone sometimes is having at some places this kind of situation. And in past when we did not have much solutions, so these parts were full of water, and now that water table has been lowered in locally. So, now only in monsoon season you can observe that all of a sudden you see water is coming from underground, even in a plain area. This Bhabbar zone is a plain area. So, the recharge is happening, the water table in that Shivaliks or in Doon Valley is there, whereas here the water table ground level is much lower. So, you find artesian conditions for some time, but there might be some situation. I have observed one in Sonbhandar district where completely artesian conditions were there throughout the year. So, when the piezometric surface of a confined aquifer is above the ground level, then the confined aquifer is called artesian aquifer. This is a if somebody gets this thing, then you may get the water round the year without any pumping, without putting any energy. That is the best solution if one can find. So, in case of artesian aquifer, if a well is put, then the water will come out of the well automatically, completely automatically, because of the pressure of water within that aquifer, and this is really ideal condition if one get the water. But this can be if extensive investigations, ground investigations are done from hydrologic and groundwater point of view, then at places these conditions can be found discovered. So, I will just cover in summary will cover and will then end this discussion, that is the comparison of these different groundwater formations or different types of aquifers. So, first is the aquifer, then aquitard, aquiclude, aquifuges. So, water storage, all three are having that capability, yes, 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 but water storage in aquifuges not possible. Fuse, it does not have permeability, it does not have porosity. Permeability of water in aquifer, of course permeable, aquitard partly permeable, aquiclude impermeable, and of course in aquifuges also impermeable. Yield of water, the best situation aquifer, where yield of water is possible, water can be withdrawn, good yield means good output from tube well can come, but yes, slow yielding. So, you withdraw water for some time, leave the well, and then after a few hours or maybe next day you withdraw the water. These are the solutions in case of one encounters the aquitard instead of aquifer. Aquiclude do not yield, will not give you water, and of course aquifuges no possibility. Another examples, what are the formations which can create such situations. So, in case of aquifers, sand and gravel, gravel is the in that way the movement of water is the very fast, but sometimes it may disappear also quickly. Like we know that in this Doon valley, it is filled with more larger sediments compared to sand. So, as soon as rainfall occurs, the water goes down because of gravel. The movement of water is very fast. So, sandy, gravel, which are example of aquifer, Aquitard clayey sand or sandy clay, that is an example. Aquiclude, purely clay, will not allow water to move, and these are aquifuges are generally compact rocks such as granite, basalt and other things. And let me add little bit about the basalt. Basalt sometimes is having vesicles inside, means the gas was trapped when these basalt layers were formed. Now that gas may be trapped or may not be now, but the permeability is very poor. So, some porosity because of these vesicles might be there, but permeability is poor, and therefore, we consider basaltic rocks or hard rock granite as aquifuges. So, with this I end this discussion. Thank you very much.